We're here to talk about migration from sidecar to Istio ambient. How many of you actually heard of Istio ambient? All right, everybody, how many of you actually tried Istio ambient in your cluster? A few of you. Wow, I'm impressed. Okay, my name is Lisa. I'm the head of open source at Zero-Downtime. I've been actually contributing to Istio since 2017, if I remember correctly. Almost 2 years, but not quite yet. Harri, can you introduce yourself?
My name is Ahmad Al-Masry, and I am a DevSecOps engineering manager at Harri. Okay. So, just a small introduction about Harri. Harri is a leading AI, agentic AI platform to manage sorry for this. So we are a leading agentic AI platform to manage the workforces, the workforces in the hospitality sector. So we currently serve about 19 million hospitality employees that are working for about 750 clients that we are working with that are distributed over 55,000 locations worldwide. And these are some of the brands that we are currently working with. So our journey with service meshes started when we started to adopt Kubernetes to host our applications, approximately about June 2021. And for that, we used AWS App Mesh. AWS App Mesh was the service mesh offering provided by AWS. It is Envoy proxy based, and it is designed to work for EKS, ECS, and EC2. And that thing was crucial for us because we wanted to do canary migrations between Kubernetes and EC2. After we have adapted a App Mesh, Istio started to work and to introduce the ambient mode, and that was about in September 2022. And Istio continued working on ambient, and it was in beta, and that was released in May 2024. But suddenly, in September 2024, AWS has announced the deprecation of App Mesh. And this is actually what brought us to this point. After that, we started to evaluate multiple options, and we will be discussing them soon. But we ended up using Istio and sidecars for the dev environment. And during that, the GA of ambient was released with the release of Istio 1.24, and that by November 2024. So after that, we tried to give ambient a try, and we deployed that on the dev environment. And the testing was very successful, so we ended up finishing the whole migration for all of our production environment by February 2025. So before migrating to Istio and ambient, our topology with using for Ingress with using AWS App Mesh, it was like the figure displayed. So actually, for the Ingress traffic, all the traffic goes through AWS CloudFront, which is protected by AWS WAF, and that is configured also to be forwarded to AWS API Gateway, which is integrated with AWS Cognito to do the authentication and authorization. AWS API Gateway was configured to forward the traffic to AWS NLB, which was serving the App Mesh virtual gateway. And the virtual gateway by itself will forward the traffic to the needed Kubernetes service and deployment. It is worth mentioning that App Mesh is based. It was using Envoy sidecars, so all of these sidecars and pods have a proxy container within it. So after the deprecation announcement done by AWS, we tried to set some kind of guidelines to guide how the selection criteria of the new solution will be. So we decided that the new solution should have a very large user base and it should be production proven and it is not controlled by a single enterprise. The other point that we wanted to have is to have a solution that have more features than what we already have in AppMesh. And preferably, we wanted to have a solution that is open source with a very big community to support. And we also tried to have some kind of preference to have an in-place cluster migration. So we ended up by evaluating four main projects. The first one was AWS VPC Lattice. And this is a project that is provided by AWS that is proposed to replace AppMesh for AKS. But we ended up not using AWS VPC Lattice because VPC Lattice was very new at that time, and it also lacked many of the features that we already have by using AppMesh. And also, to be honest, AppMesh was not the first and is not the last AWS service that was deprecated after we have adopted that. So we just did not want it to go to VPC Lattice and to end up with a deprecated service again. The other option is Linkerd, and we did not choose Linkerd because of our concerns of how they distribute the stable binaries. And also, most of the decisions for Linkerd are driven by unit. And we did not just want to feel the DW that we have felt by using Redis and Elasticsearch when they switch the licenses. The other one was Cilium Service Mesh, and to be honest, Cilium Service Mesh was a very appealing option. But our main concern with it is that in order to use it in full feature, we need to switch the VPC CNI. So in order to use that, we need to switch the whole networking infrastructure that we want just to have the service mesh capabilities of Cilium. And that brought us to Istio. So we ended up selecting Istio because mainly it is an open source and it is backed by the CNCF. And it is driven by multiple enterprises that steer within its steering committee. The other thing is that Istio has a very large user base and it is production proven and already adopted by many cloud providers in addition to many large enterprises. The other thing that also we had in mind is that Istio is in sidecar mode, is very similar to most of the concepts and the configuration that we have for AWS AppMesh. And it was also based on Envoy proxy, so that reduced the amount of information and knowledge we needed to gain in order to understand how Istio works. In addition to that, Istio provided many more features than what we already have with AWS AppMesh. So, for example, in traffic management, they provided locality load balancing, mirroring, fault injection, and they also provided a mature integration with progressive delivery solutions like Flux and Argo CD. They also provided many security features that AWS AppMesh was lacking, like the authorization policies, either it is on L4 or L7. In addition to have a built-in integration with any JWT token providers. And last but not least, the extensibility of Istio by using WebAssembly. So, as you have heard from me, during the testing of Istio Sidecar, it was about just a month that ambient was released, and so ambient was very new. But even that, we tended to try it because we have faced a couple of issues that using Istio a sidecar backend that we are actually facing with Applish. And we can mainly summarize them with three R's: restarts, race conditions, and source overhead. What we mean by restart is that every time we need to upgrade a app mesh or Istio, we needed to restart the whole pods within the mesh to pick the new a proxy sidecars. For the race conditions, at least before the introduction of the sidecar containers and the pods, there was some connectivity, network connectivity issues if the sidecar has started before after the application container, or it has been shut down before the application container was empty. And the last one is because every pod needs to have a proxy within it. There is a lot of resource overhead that is consumed by these proxy containers. And we saw the advantage in ambient. The community was very active and was very helpful, and we were engaging with them through Slack and GitHub, and and some of the features that we had requested were get implemented in ambient. In addition to the L4 and L7 separation, which also improved the traffic by reducing the latency by this separation. And it also provided much better resource utilization by being able to slash about 40% of our container count because of dropping the sidecars.
All right, so I'm going to explain a little bit more about ambient. Do you prefer me explain ambient in a few minutes, or do you prefer to see a quick demo? How many of you want to see a demo instead? And how many of you want to see slides? Okay, listen to me. All right, let's do it. In a few minutes, I want to show you in my cluster, I have Istio ambient already installed. I have zTunnel and Coyote premises. I have a demo application. Can you see in the back? Is the font good size? Yes? Okay. I have my demo application installed. I have a RAG version 1 and version 2 installed. And notice I'm not having any sidecars. And in my default namespace where I'm running my application, you can see I enrolled the paths in the namespace into ambient by simply labeling the namespace with Istio.io data plane mode equals ambient. I only deploy a waypoint. I also deployed a waypoint proxy in the namespace because I have layer 7 traffic. So you don't actually need a waypoint unless you have layer 7 traffic or layer 7 policy enforcement, or if you need layer 7 observability. So if you go back to the default namespace, you can see this is my waypoint. All right, so I also have HTTP routes configured. I have two of the routes. One of the routes, which is the demo routes, it configs from the Istio Ingress Gateway to the demo application. And the RAG route, which we're going to open up quickly, is config everything goes to RAG version 1. So hopping on to the demo application, by the way, the reason I developed this demo application is and add the RAG component is because when I chat with a large language model, if the model is old, it doesn't necessarily understand Istio ambient. So hop onto the RAG demo here. I have two versions of the RAG. Version 1 doesn't handle TXT file. It only handles the PDF file. Version 2 handles the TXT file as well. So you can see right now, because the HTTP policy, I have all the traffic always goes to version 1, so it doesn't handle the TXT file. So just to save time here, I'm going to quickly shift the version 2 to 100 and shift the version 1 to 0. And then we're going to go ahead and deploy this configuration. And we should be able to see this live in our cluster and have the traffic mediated by waypoint proxy. And if we load right now, finger crossed, it does goes to version 2. So I'm going to ask, what is Istio ambient mesh? If there's one thing about Istio ambient mesh, I want you to take away. Hopefully, this provides the answer, remove the need for the sidecar, building on the traditional concept of service mesh. All right, just quickly wrap up this quick demo. This is actually what I just demoed. I'm going to change this to maybe a little bit longer because I think the reg version 2 wasn't rendered. So you can see the traffic didn't go very well with version 1, and the traffic goes pretty well with version 2. By enroll my pods in ambient, I got not only meter TLS, I got traffic enforcement. I could add authorization enforcement. I also get observability at HTTP level. So it's very, very simple considered to the traditional sidecar approach. All right, with that, I'm going to wrap up quickly to give to Ahmad to talk about the migration story he's been having in Paris. Go ahead.
Thank you, Lynn. So before doing the migration, this migration happened on the same EKS cluster. So we did not need to create any new EKS cluster, and we were being able to migrate in place from AppMesh to Istio Ingress. And this starts by creating a gateway custom resource from the Gateway API to deploy the Ingress. And by doing that, we have both services and two AWS network load balancers that are coexisting on the same EKS cluster. It is worth mentioning that if you just want to use the Istio Ingress Helm, you can just deploy the Ingress using the Helm and mention that in the address section of the spec of the gateway object. And after that, we create a default route. This default route will actually forward all the traffic that is reaching the Istio Ingress gateway to the AppMesh virtual gateway service. And by doing that, we are trying just to put Istio at the beginning of the networking stack that we have to be able to gradually migrate the services one by one. It is also worth mentioning that we may be needing to have a reference grant, and this is to allow Istio Ingress to talk with another service that is located in another namespace. And to create the default policy, this is a sandwich route object. And the highlighted lines displays that we just created a path with a slash to match all the traffic. So after that, we switch the traffic to Istio by configuring the API gateway to forward the traffic to the NLV that serves Istio Ingress gateway instead of the AppMesh virtual gateway. And after that, for the north-south traffic, we start to enroll the services or the namespaces one by adding the annotations to enroll into the ambient backend for Istio. And we do this step by first removing the annotations for enrolling into AppMesh and adding the new annotation for the namespace to enroll into Istio, and create an HTTP route that has the prefix for that microservice. So the match for that service will be by the longest match for the path. After that, for the southwest traffic, because there is no actual integration between AppMesh and Istio, we ended up by disabling the MTLS or making the MTLS optional for the Istio side. This is because we can just provide a single SPIFFE and certificate manager and the certificate providers to make the MTLS happening. And also for the east-west, we can also optionally deploy a waypoint gateway. This will help us to do some kind of L7 capabilities like the weighted shifting for the services and to do canary releases. After that, after we migrate all of the microservices to the Istio gateway, we just to the Istio mesh, we just validate that there is no any traffic remaining by just validating the access logs for the app mesh gateway. And we do any needed cleanups, just for example, to remove the gateway and any CRDs deployed for app mesh. And after the migration of the after the completion of the migration, the setup should be like this.
All right, thank you. I am glad you were able to migrate from AppMesh to Istio Ambient. It sounds like your migration is pretty successful, so thank you so much for sharing your story. I do want to call out a couple of considerations. Well, your story with AppMesh Sidecar does apply, most of them to Istio Sidecar to Ambient. I assume most of you are using Istio Sidecar, is that correct? How many of you are actually using AppMesh Sidecar? Okay, how many of you are actually using non-Istio sidecar? How many of you are using Istio sidecar? All right, okay, cool. Sidecar to ambient migration, a couple of caveats I want to call out. If you are looking at sidecar and ambient interrupt, if you don't need any layer 7 function, how many of you need layer 7 function today? I assume it's many of you. Okay, so if you don't need layer 7 function, sidecar and ambient interrupt is pretty straightforward. You can have ambient and sidecar interrupt. The only caveat is you do need to make sure your sidecar support edgeable by enable ambient and restart your pod. You will be able to upgrade your sidecar to support edgeable. However, if you have layer 7 functionality, you need to enforce. If your client is a sidecar and if your destination, which is on the server side, is in ambient, the client doesn't realize the destination has a waypoint. So right now, it won't work very nicely. In Ahmad case, it works okay because he's able to tolerate. He had neutralize disabled during the migration, so he was able to tolerate not having zero trust all the time during migration. He was able to tolerate not always have layer 7 policy enforcement during the migration period. So you have to judge if that's possible for your scenario. What I do recommend, if we do need a layer 7 policy enforcement, what I do recommend is you have kind of like a blue-green architecture where you have sidecar running end-to-end, and then you have also ambient running, maybe in different namespaces end-to-end, and then use the Istio ingress to gradually shift the traffic at the edge layer. So that way you don't have to worry about sidecar to ambient interrupt and the caveats come with it, particularly when you have layer 7 policy enforcement. On the migration step, just recap, you want to enable ambient profile in your Istio environment first, and then you will have to need to kind of pick up the new sidecar that has edgeable enabled, so that enable your sidecar to be able to talk to destinations that can understand zero trust, the Z-tunnel and waypoint. Then you can go ahead and deploy the waypoint, but doesn't mean you are using it. Remember I talked about in my demo, use waypoint label is what dictates whether your waypoint gets used. So when you have your waypoint deployed, you can test it, but not actually having it be used. And then you can start looking at your policy. So there are some differences with the policy between your sidecar to ambient. The biggest difference is the policy attachment, especially on OSC policy. The community works really hard on OSC policy to make sure we have good status for you, to make sure that you can always check the status to help you debugging on that. But the policy attachment is different. It's no longer using workload selector. It's more using target rep to target particular services. There are some other policy that's different. That also in the category of workload selector to target rep. WASM is another. WASM policy is another one. I think request authentication is another one. So do watch out for those. And then once you feel comfortable about your policy, you can start enable your waypoint. That's when the use waypoint label is effective, and then you can have your waypoint enabled. And then at the end, because you have this policy applied for your sidecar, you also have this policy applied to ambient. At the end, you can look at potentially simplify some of your policy and then remove the sidecar completely once you feel very comfortable about your ambient environment. So I'm sorry, the migration step is not as easy, but as you see in my demo though, the benefits of ambient is really, really simple. Like I feel confident that anytime I can pull out the demo and show people, and without all the operation complexity I want to just talk about. Network policy, just a little bit caveat if you're not familiar with ambient, because all the traffic in ambient is on H1 port 15008. You do want to make sure your network policy allow traffic communication on that port. And for waypoint and Istio Ingress Gateway, you do want to make sure, because waypoint is an additional component, you want to make sure the waypoint have access to your destination service through network policy, not blocking that, and also similar configuration on Istio Ingress Gateway. All right, I'm going to pass to my co-speaker Ahmad to talk about some of the challenges he run into.
Thank you, Harri. So I'll try to read it as much as I can. So it is mainly some kind of nodes that were mentioning after the migration. So one of the limitations that AWS API gateway, HTTP API gateways, is that it has a limitation of 30 seconds for the integrations. And this includes the integration with an NLP. And this mainly will be a blocker for handling AI agent HTTP streaming requests, which in most of the cases it will take more than 30 seconds to complete. So in order to have that and to also be able to make use of the authorization policies and authentications that is done by AWS Cognito, we use the built-in integration for Istio waypoints with the JWT providers and integrated that with Cognito provider to drop the use of API gateway. So we ended up deploying a new API gateway, a new public network load balancer that is speaking with the Istio Ingress Gateway. And the Istio Ingress Gateway, instead of forwarding the traffic directly to the services, it needs to pass that to the waypoint, which will do the layer 7 authentication, validation of the JWT token provider by integrating with the JWKS file for Cognito. So to configure this, I just want to go with the highlights. So the destination service should have the label, which is Istio.io Ingress Waypoint True. And we updated the network policy to allow what already Lynn has mentioned for any service to be able to communicate with waypoint by allowing the port 15008. And also we enable the namespace for the waypoint in case we are using a waypoint in a different namespace. After that, we just configured a request authentication that uses a AWS Cognito as a JWT token provider, and we use that in the authorization policies by specifying the request principles to match the same issuer and to match the same token information that we have from AWS Cognito. It's also worth mentioning that for the pre-flight requests and the options requests, Istio does not expect these calls to be authenticated, so we just drop the request principles.
Can I do a quick time check? I noticed we're 7 minutes over, so I want to be respectful of your time. We probably should wrap up, unless, because I didn't see any alerts on timing. Should we go ahead and wrap it up? Yes? Okay, I saw you now, Keith. So I apologize for the run over because we had a delay start. But yeah, just to wrap up, I think we had a successful migration story from Ahmad to Istio Ambient, and the same migration story could be applied to Istio Sidecar, to Ambient, and we will be around if you guys have any questions regarding migration. So thank you so much, everybody, for attending our talk. Really